I'm Tyler Hunt, and you can find me on Twitter and GitHub at Tyler Hunt. I work for MB Labs, a little Rails consultancy in Orlando, Florida. And I also blog over at devo.com, so you can look there later for the slides to this talk. So I'm sure we can all agree that Ruby is great. Thanks to Mats, we have a language that's a joy to use, and it's why we're all here today. But a big part of that joy comes from the flexibility that Ruby affords with creating libraries and frameworks that make our lives easier. With nearly 29,000 gems now on rubygems.org, the true beauty of Ruby is found in its vibrant community of gem contributors. We have a plethora of choices when it comes to libraries and frameworks. And while that's great, it can be problematic sometimes too. Take ORMs, for instance. We have Active Record, Data Mapper, SQL, OG, and then web frameworks. We have even more choice. We have Rack, Rails, Sinatra, Padrino, Merb, Camping, Ramaz, Nitro. And what this means is we have lots of choice. Every day that goes by, there are more gems than ever to choose from. And this brings with it some great benefits. Having choice allows people to experiment with new ideas and break conventions. And it also allows people with differing opinions to be able to thrive in our community without having to abandon the language entirely. But it comes with some detriments as well. It can be confusing and frustrating for new users to have to decide between multiple libraries that perform the same function. And then we also have to deal with varying levels of code quality and determine which gem of the ones that do what we want is the best. So what's the solution to this? How do we fix it? Well, what needs to be fixed? I mean, we don't want to stifle innovation or limit people's choices, but there is an overall need to improve the quality of some of the gems being released. So that's kind of what I want to focus on today. We've got the quantity, so let's increase the quality. So we're going to start by walking through the steps involved in creating a modern gem, and then take a look at some of the conventions that will result in better gems, and then close with kind of where we are today with the Rubygems ecosystem. Let's first go through what's involved in creating a gem from scratch. Some of this material is geared towards showing how to make gems, but it's also going to touch on some of the conventions that we'll go into a little more later. We're going to walk through the steps to create a new gem called Stardust. The name comes from a great little indie coffee shop in Orlando called Stardust Video and Coffee, where I've been co-working every Tuesday for the past couple years. And it's not actually going to do anything, which is why the name doesn't really matter all that much. It's just going to contain everything but the functionality needed for our gem. So the first thing we want to do is create a directory to hold all of our files. And we'll name this after the gem that we're creating and switch into that directory. And then we're going to edit our gemspec. Now, the gemspec is a file that defines all the meta information about our gem. That includes things like the gem name and the version, the author and email address for the author, and all of the dependencies. And this is what kind of the core of the gemspec looks like. And these are the required fields: name, version, and summary. That's all you need to start, but you probably also want to add in some of those other fields like authors, email, homepage, etc. You can get the full list of those parameters in the gem specification reference at docs.rubygems.org. And then once we have this, we're actually able to build the gem. And this will create the gem file for the version specified in our gem spec, just gem build and then the file for the gem spec. Since we haven't listed any files yet, there won't be anything included in our gem other than the metadata itself. And gem file is actually just a tar archive with a gem extension. So if we kind of look here at extracting those files out, you'll see there's two files inside. It's data.tar.gz and metadata.gz. And every gem is going to look this way, regardless of what it includes. The metadata file, after you unzip it, contains a YAML file containing the metadata we defined in our gem spec, plus some additional information that Rubygems adds in when it's building the gem with defaults and that sort of thing. And if we look at the data file and extract that, we see all the files for the code included in our gem. In the case of our Stardust gem, there aren't any files yet, so this will just be an empty archive. So let's add some files. We'll create a directory first called lib, and this is where all of the files, all the code for our gem lives. This is where our Ruby files go. We make the directory from within the Stardust directory we created originally, and then we're going to add our first file, stardust.rb. And this is just named after our gem as well to make it simple for people to know that if they install the Stardust gem, they can require Stardust to load that gem. Inside that file, what we want to do is, again, create a module with the same name as the name of the gem. And this is going to be responsible for kind of namespacing all of the code within our gem. Now we'll jump back into the gem specification again and tell it about the directory we've just added. The gemspec has a files attribute that is just an array of all the files you want bundled inside that data archive within the gem. These paths are all relative to the root of the gem directory, and the gemspec is just Ruby, so we can use other libraries and Ruby facilities to kind of generate that file list for us if we want to. The require paths line just lets Rubygems know that it's the lib directory that should be added to the load path, and this value of lib is actually the default provided by Rubygems, so we don't actually need to add this line to our Rubygems. We can just rely on that default. I'm sorry, to our gemspec. Next, we want to kind of create a subdirectory under lib, again, named after our gem. And this is where the rest of our files are going to go, so that we don't clutter up the load path. Keeps all the files in the gem from being directly accessible via require, kind of putting them under that directory. So everything has to be required via stardust / whatever if we want to require something underneath that directory. Now, I want to go over the version a little bit. We do have a version defined in our gemspec, but we're going to go ahead and create a second file called version.rb under that stardust directory. Now, this file isn't required since we have already defined the version in the gemspec, but it's become a fairly commonplace practice to do this sort of thing, and it gives us some additional benefits. That file just contains, again, our module stardust and then a constant defining our version. And that's it. That's all that goes in the file. But this is going to allow our gem users to programmatically kind of determine the gem version when they're using their applications. It's possible to get this information through some of the Rubygems libraries, but that kind of gets messy and it doesn't really work for everyone. So this is an easy way for people to kind of determine what version of the gem they're running. The problem now is we've got the version number defined in two places. It's here in this file, and then it's also in our gemspec. So before we jump into the gemspec, we want to open up that Stardust file again as well and require Stardust version. And this means that if somebody just says require Stardust on our gem, they don't have to also require Stardust version to find out what the version is. So and this is how you'll require all the sub-files for your gems as well, just using stardust / since that Stardust directory is going to be in the load path thanks to the lib directory being added. Back into our gemspec now, we see we originally defined the version number just as a hard-coded string. So we're going to update that to use the constant we just defined. We've got to add 2 lines here just to add the lib directory to the load path and then load in our version file. I'm not a huge fan of modifying the load path here, but that's kind of been the established convention. At the end of the day, this is just our gemspec, which is only used when we're building the gem. So modifying the load path shouldn't really be all that big of a deal. Then we're going to swap out that version line with the constant we've defined instead of using the hard-coded string. So now when we need to update the version of our gem, we just edit that version file, and we don't have to do it in one place, and we don't end up with duplicated version numbers that could veer off from one another. And then we can ship it. With all that, we have the core of our gem built out, and we're ready to actually push this out to the world so everyone can hook up the Stardust gem in their own apps. So the first step is to build the gem file, and this, again, just uses the gem command, gem build, in our gemspec file. And we did this once already, but we need to do it again since we made some changes since then. And once it's built, we can use gem push to push the gem up to rubygems.org. And this does require that you have an account in place on rubygems.org, but I think it kind of walks you through some of those steps if you don't have that set up already. And this will make it publicly accessible to everyone to install via gem install. And as kind of a nice side effect of this, after you push your gem to rubygems.org, you'll get your 15 seconds of fame as on the top of the list for the new gems on rubygems.org on the front page. And that's it. That's all there is to building and releasing a gem, aside from actually implementing your gem. But one thing we haven't discussed yet is how your gem can depend on other gems. And dependencies are the mechanism for that. They let Rubygems know what libraries need to be installed in order to use your gem. They're specified, again, by adding additional lines to the gemspec file. So here we've added a runtime dependency on active support and a development dependency on RSpec. Now, development dependencies are used for dependencies that are only needed when developing your gem, and they won't be installed by default when someone installs your gem. So if we do gem install stardust, and after we kind of rebuild the gem, and we'll see that those dependencies are installed, but it's just active support. We don't see RSpec there, and that's because it's been defined as a development dependency. If you want those development dependencies installed, there's a flag on gem install -- development that will install them for you. Be thoughtful, though, when you're choosing your dependencies. If it's just simple functionality that you need, you might want to just write it yourself in the gem rather than requiring additional dependencies, because every dependency you add has the potential to complicate things and introduce further conflicts when people are trying to pull this gem into their own applications. There's also a small gotcha to watch out for. There's a post up on rubygems.org right now that kind of details an issue with parsing that YAML metadata file, and it has to do with whether it's being parsed by psych or sick, the two different YAML parsing libraries that exist right now. The TLDR on that is that rubygems.org needs to be fixed, but in the meantime, there's a workaround in the latest version of Rubygems, 1.8.10. So upgrading to that version will work around this. Another way is to just avoid using equals dependencies in your gems. So use greater than equal to or use pessimistic kind of locking. And that should keep this issue from popping up. Bundler. Since we're talking about dependencies, let's talk about Bundler for a minute. When we're doing gem developments, Bundler provides us a couple of useful tricks. So the first thing we need to do is add a gem file within our gem directory. And that gem file is just going to be 2 lines. We have the source defined, and then we have this gemspec command. And that's the first assist we get from Bundler. This is a shortcut that tells Bundler to consult our gemspec to determine our dependencies. All your dependencies should be defined in your gemspec, not in your Bundler file, so we don't end up having to define them in multiple places. And now when we do Bundler will consult that gemspec file and install all the dependencies based on what's defined there instead of what you typically do, which is adding those to your gem file. The other feature Bundler provides to us as gem developers is bundle gem. And this effectively automates all the steps we've seen so far, plus some more things. It also initializes a Git repository for us and sets up a Rake file with some helpful tasks. So a lot of this kind of hand coding stuff we've looked at so far can just be done with bundle gem if you're using Bundler. And then once that bundle gem command has been run, you'll see everything that Bundler has done for us. We've got the libstardust.rb file and the version RB file we took a look at. We've got the gemspec set up already referencing that. And then we've also get our gem file, a Rake file, and our getignore file already set up for us. And now we're just a command away from the first commit to our new gem. Bundler also defines 3 Rake tasks for us to use when we're doing developments as well. We get Rake build, which will build the gem for you. And this is basically just the same as doing gem build stardust.gemspec like we saw before. But it's simpler to type, and it allows us to, it will also place the gem into the package directory where it will be ignored by the getignore file, kind of keeping the root directory tidy. There's Rake install, which will build the gem and then install it into your system gems. And Rake release, which is probably one of the most useful, and this will create a Git tag for the current version number then build the gem, and then push it to rubygems.org for you, kind of automating the release process even further. Before you push, though, you should really be writing tests for the code that you're writing. As good Rubyists, we know how important tests are to code quality, but with gems, they're even more important since you'll have other people relying on that same code within their own application. So the key thing to remember here is just to make sure that you're writing those tests. And it doesn't matter if you're using test unit or rspec, as long as you're testing the gem. So there is one thing to keep in mind. Test unit, when you're writing gems, will actually add the gems lib directory to the load path for you, so you can just require relative to that. Rspec doesn't do that, so you'll have to add that to your spec helper yourself. This is what the spec helper might look like in that case, and it's just a matter of kind of adding that lib directory onto the load path and then requiring your gem into it as well. And then make sure you add rspec as a development dependency of your gem and not a runtime dependency, so people using your gem don't have to have rspec installed as well. You should also be looking for tests when evaluating gems you've never used before. Reading through a gem's test gives you a fairly good picture of the overall code quality of the gem, and the absence of tests in a gem should at the very least cause you to hesitate before adopting the dependency into your application. So now that we've seen kind of a rough overview of how to create the gem, we're going to go through some additional conventions to keep in mind when doing gem development, some practices we haven't touched on yet. All the code needed to use your gem should be placed into the lib and bin directories. Bin is just used for command line tools and that sort of thing that are actually executable after installing your gem. In some cases, when using non-Rubygems package managers, things like RIP, anything outside of these two directories won't even be loaded. So it's a good idea to stick with those directories when you're on gems. Keep all your code within a module with the same name as your gem. This ensures that you won't inadvertently clobber someone else's classes or modules with ones in your own gem, and it keeps everything your gem provides encapsulated and avoids cluttering the global namespace. Don't pollute the load path. Your gem should never need to modify the load path. The gem packager handles all that for you. So be careful what you place in lib, though, since it will be directly requirable. Anything under that lib directory is just a require file name away from being loaded. So it's a good idea to stick to just using the RB file named after your gem. Since lib is added to the load path, there's also no need to use things like expand path or __ file when requiring files within your gem. Just require them relative to lib. There's also no need to require Rubygems anywhere within your gem. If someone's using your gem, they've already got Rubygems loaded or whatever package manager they're using. So adding this require just forces people to have Rubygems installed, which might not necessarily be the case. If you do run into cases when you're developing your gem where Rubygems isn't loaded, rather than adding that require line for it, just use something like ruby-rubygems or set rubyopt to Rubygems, and either one of these will load Rubygems for you without forcing you to modify your code. Don't use class variables when configuring your gems. I see this most often with API client gems where the authentication credentials are provided at the class level, and this can be problematic because it prevents users from having multiple instances of that service with different credentials defined at the same time. So sticking with instances for configuration allows for more flexibility in how your gem is used by your users. Okay, this is a big one that not many gems get right. All the potential errors from your gems should use an error class defined by your gem. This means that if you have dependencies that might be throwing exceptions, you should be catching those exceptions and re-raising them kind of wrapped in your own error classes. So as an example of this, inside your module, you want to define a base error class, which any additional errors used in your gem should inherit from. And the idea here is that people using your gem shouldn't have to know about its internals in order to handle exceptional cases. They should be able to do something like this, where you have a simple rescue block for the base error on your gem, and you shouldn't have to expect to receive any other error when dealing with that gem. And this goes especially, again, for gems that interface with web services and use dependencies like REST client. I shouldn't have to know that which HTTP library my gem is, or the library I'm using is using to rescue its errors. I should be able to just rescue a single error defined by that gem. Testing, do it. Documenting, it's even easier to overlook documentation than it is to skip out on testing, but having a README is critical to gem adoption and should be considered vital to its success. At the very least, you should be describing what the gem does and how to get started using it. So it's easy to quickly see how it works and what it does when you're browsing around on GitHub. Packaging, write your own gem specs instead of complicated Rake tasks and gems like Jeweler. It's easy enough to write yourself, and it makes it easier for people to build your gems too. So then once you have your gem spec, building the gem is just a matter of gem build. You don't have to worry about installing other gems just to build your gem. For any of you who have used RubyForge before, you know the pain of having to set up new projects, get them approved, using the web interface to upload gem files. But thanks to the new Rubygems.org, you're just a gem push away. It's a good idea to also create that Git tag when releasing a new version, so people who are trying to debug issues can look back in the code and at that particular tag and view the source code. Having a good versioning strategy also plays a big role in releasing gems. Tom Preston Warner has proposed a specification called semantic versioning, and many in the Rubygems community have begun to adopt this specification, and for good reason. It makes a lot of sense, and it solves issues that have been problematic in the past and provides some standardization for how everyone's versioning their gems. It's called semver for short, and there are a few basic requirements that it defines. The first is that your gem provide a well-defined public API. This means that the interface used by consumers of your gem is clearly delineated from its internals, either through code, for things like method visibility indicators like private, or through the documentation. The next is the use of a 3-part version number with major, minor, and patch versions, and each must be an integer and be increased numerically. And once a specific version has been released, the code for that version must not be modified. Think of it as an immutable release. So once it's out there, if you want to change something, you have to increment the version number. The major version 0 is reserved for initial development and should not be considered to have a stable public API. There's still a lot in flux if you see a 0 version gem that's using semantic versioning. The patch version should be incremented if only backwards compatible bug fixes are introduced, where bug fix is defined as an internal change that fixes incorrect behavior. The minor version should be incremented if new backwards compatible functionality is increased to the public API. So here you haven't broken anything that was already released, you're just adding new functionality. If you're breaking backwards compatibility, the major version must be incremented anytime backwards incompatible changes are introduced to the public API. After seeing these definitions, it should be clear why the requirement of well-defined public API is necessary for a versioning scheme, because depending on what type of changes you're making to that public API defines which part of the version number should be incremented. There's also a requirement that if you create a new version, you tag that version in version control like we've already talked about and precede it with a V as the tag name. Now, once a gem is using semantic versioning, you can use pessimistic locking on your dependencies at the major version level. And rest assured, there won't be any upgrades to that gem that will break your gem with a minor or patch level version change. The specification is hosted at semver.org, and it's short and easy to read, so I'd encourage all of you to read the full specification if you haven't already. One of the greatest parts of releasing your own gem is getting feedback and contributions from people who are using it. Having that sort of instant feedback and the ability for anyone using your software to send patches, to fix bugs, and add functionality is amazing. So don't take that for granted. Of course, much of the credit for the more recent proliferation of community contributions must be given to GitHub and for the incredible job it has done reducing the friction required to create, send, and merge patches via their forking and pull request features. Anyone can fork a project and make changes themselves, and those changes can be contributed back to the project via pull requests. So letting people know that you're open to accepting such contributions to your project might just encourage more users to give back in the form of code contributions. You can add that into your README. Bumping versions. For contributors, do not bump version numbers as part of the changes you're contributing. Version changes should be separate. Should be a separate commit from the code you're requesting be merged in, and not be in that pull request. This allows gem maintainers to handle version changes on their own schedule. It makes it easier for them to merge in the pull request through things like the web interface. Ruby's seen a huge amount of growth over the past few years, thanks in large part to Rails, but that's meant a lot of new developers coming onto the scene from all different backgrounds. The gem ecosystem's been flourishing ever since the switch away from RubyForge as well. And I'll just reiterate this point again. The number of gems has essentially doubled since the transition over from RubyForge to rubygems.org. And lowering the barrier of entry makes it easier for developers to release new gems. And part of that barrier to entry is making releases easier. And thanks to rubygems.org, releasing new gems is now as simple as gem push. Gone are the days of waiting for project approvals and uploading gems via a web form. You can just push now simply as gem push. But quantity doesn't equal quality, as you're all well aware. With that new code being released, we end up with a few questions we have to ask ourselves sometimes. One of those is whether to use an existing gem or write one yourself, or just write code within your app to handle it. There's a lot of code, great code we can use now, but when you start getting into some more obscure subject areas, obscure web services, and that sort of thing, this question becomes a little more relevant. Another question is duplication. How do we decide between several different gems that do the same thing? You don't want to limit innovation, but choices can be confusing to newcomers. Take, for instance, JSON gems, and also the multi-JSON meta gem, and then XML gems, where you have things like hprocod and mkdir. It also presents a lack of focus on the part of the community. It's tempting to want to rewrite gems. We're easily distracted by what's new and shiny, and we love to reinvent the wheel. But sometimes we'd be better served by spending that time improving what already exists. So think twice before starting development on a new gem. What we've looked at today is how we can extract and define some simple conventions that go a long way towards improving code quality for everyone. And now that the barrier of entry has been lowered, the ecosystem is thriving and flourishing. So there's never been a better time to introduce new gems. So I hope you'll be able to take away some of what we've discussed today to get out there and create something new. So I want to say thanks to a few people for getting us to where we are today. Thanks to Nick Carranzo for putting in the work to make rubygems.org a reality, and ThoughtBot for making it pretty for us to use. Thanks to Yehuda and Carl, collectively known as Carl Huda, for spending their countless days developing Bundler. Thanks to GitHub for giving us amazing tools that advance the state of open source. And thanks to everyone else who's ever released a gem. Our community is all the richer for the value you guys have contributed by shipping code. Can I answer any questions? Yeah.
With semantic versioning, the question I have is, what about things like release candidates and so forth? These are very common things that come up, and it does not, in fact, fit the requirement. So then what do? You don't have a release candidate release. You just release 2.0.0 and
that is actually covered by the specification. I didn't mention it today, but if you're doing release candidates, you can just append something like RC1 to the end of the version number without a dot. So it'd just be 1.0.0 RC1. And that's defined in the spec.
okay.
Yeah.
I implemented a gem that handles semantic versioning for you, and if anyone wants to take a look at it, it's called version, simply enough, but it automatically it keeps a version file of the root of your project and will read it into a module of your choosing. But then also there's Rake Tasks that let you bump it, bump pre-release versions, bump whatever the lowest increment is, bump a major version, and it can even automatically get tagged them for you if you want. And it just makes doing that, takes rid of the friction. So take a look, It's just called version.
Great. Yeah, in the back.
So back when GitHub was building gems, I used to be able to fork something and say I want to fork mkdir and add something to it. Not a good example because they probably accept the patch. But let's say it's somebody who would accept the patch. It would be like my name dash mkdir. And now that we've moved to rubygems.org, is there a preferred way for doing like my version of a gem, assuming that I can't get that upstream?
Right. Well, one of the easiest things to do if you're using bundler is just to add that as a dependency in your gem file. And you can specify the Git repository as one of the parameters in the bundle in the gem file.
But I don't think I can do that. Like if my gem depends on another gem, I can't do that. Isn't that true?
Oh, so it's a sub-dependency, basically?
Right.
It'll use gemspecs.
Yeah.
It'll track dependencies of gems through Git repositories and look at the gemspec.
But he's saying if you want to modify one of the dependencies of your dependency.
Yeah, but if you could put that at the top level of your gem file, and the bundler would say, oh, you want this one and not the other, and then it would fulfill the
Yeah,
rest.
it's great if you have a gem file, but does that work in a gem spec? I haven't seen how you can do that.
Well, I think what they're saying is you can just add that sub-dependency to your gem file. And bundler is smart enough when it's resolving the dependencies to use that instead of the one defined in the gem spec in your dependency.
But as far as like pushing it up to rubygems.org, any recommendations about that? Pushing it up.
Yeah, rename it.
Yeah, just have to push it up with a different name, basically.
So no natural lineage.
Right. Anything else? Okay, well there's up front on the table here, there are some stickers and things, so feel free to grab some of those on the way out for MD Labs. We've got business cards and code school stickers, all kinds of stuff, so thanks a lot.